Here we go, Precalc. Are you ready? 2.1, example 6, completing the square. This is going to be long. Take a deep breath. Get a glass of water. Stay hydrated. Here we go. Example 6. Using algebra to describe the graph of a quadratic function. So we're going to take a standard form of a parabola and change it algebraically into vertex form using completing the square. First of all, a perfect square. X plus 4, for example, squared. When you multiply that out, you have x plus 4 times x plus 4, which then will be, let's see, x squared, no parentheses needed anymore, plus 4x plus 4x plus 16. Notice how I have two of the middle terms, and that term is squared on the end. So it's almost like you could say you have 2b in the middle and you have b squared on the outside. Just saying. Or what if you added this together? X squared plus 8x plus 16. Here you have, if you call 8b, which it is your b term, this outside guy is b divided by 2 squared. Keep this in mind. I'm going to leave that there for example 6. I'll erase it during the now try. Here we go, solving algebraically. So f of x equals 3x squared plus 12x plus 11. Alright, my first step in in completing the square is I have to get rid of the constant term as well as the leading coefficient. So what I'm going to do first is subtract 11 from both sides. So I'm going to leave this as f of x minus 11 equals 3x squared plus 12x. Now I need to divide everything by 3. I'm going to divide these separately, but this guy, I'm going to divide it all as 1 because there's really not much I can do with f of x at this point. I'm just kind of storing those over there for later. On the right side, I have x squared plus 4x. Oh, doesn't that look interesting? X squared plus 4x. So now if 4 is my middle term, like here 8 was my middle term, I divided by 2, 8 divided by 2 is 4, squared is 16. So what if I take 4 divided by 2 and then square, which is 4? So I'm going to add 4 to this side and add 4 to this side. Now I have a perfect square on this side. So I have f of x minus 11 all over 3 plus 4 equals, now on this side I have that perfect square. This one is actually x plus 2 squared. So now I'm going to move everything I had stored over here back to the other side. So I'm going to subtract 4 from both sides. I'm going to multiply both sides by 3, which means I need to multiply the whole chunk on this side, this whole binomial squared, and the 4. And last but not least, I'm going to add the 11. F of x equals 3 x plus 2 squared, and then that looks like minus 1. So now I'm going to graph this, and I'm going to make sure that this original and my final equation graph to be the same exact parabola. As a matter of fact, I think I already know what the vertex is supposed to be. -2, -1. Let's try it. So I put in the original without any work done from me yet, and then in y1, and then in y2 I put mine after all my work was done, and I made that one bold. Here we go. Oh my gosh, cross your fingers. Whee! Alright, so our parabola graphed to be the same exact parabola in the original equation. The now try problem number 33 is a little bit easier than example 6 because the leading coefficient is 1, so I don't have to divide by the leading coefficient. All I need to do is subtract 6 from both sides. So f of x minus 6 equals x squared minus 4x. So now the right side is cleaned up enough where I can complete the square. My leading coefficient is 1 and I've gotten rid of the constant term. Now my b value is technically negative 4, but if b divided by 2, so negative 4 divided by 2 is negative 2, and when I square that, it's still going to be positive 4. So I'm going to add 4 to both sides of the equal sign. So now on the left I have f of x and really only minus 2 equals, now I have this perfect square on the left side. This one's going to be x minus 2 squared. So when I multiply that all out, I would get x squared minus 2x, which creates that minus 4x. And then the negative 2 times negative 2 would be the positive 4. Last step, add 2 to both sides. F of x equals x minus 2 squared plus 2. I'm going to check that. I put in the original equation without any work done by me. Then in y2, graphing dark, I put in the answer I think will graph to the same exact parabola. Let's see what happens. Yay! The same exact parabola. Whew. Okay. It wasn't as bad as I thought it was going to be. Maybe it was for you. Sorry.